Hello world, I am Ahmed Hassab, lecture assistant at the American University in Cairo. I'm here to talk about generative design methodology for double curved surfaces using AI. Firstly, we thank Digital Futures World, Tonji University, Professor Neil Leach, Daniel Pluyan, Manus Vermesso, Shermin Youssef, and special thanks for Sora and Frank. Despite recent approaches to generate unique surfaces using generative design algorithms, there are still challenges, including teaching machines how to learn and manipulate surfaces, thus generating novel and unique versions, and exploring possible alternatives in producing unique surfaces using artificial intelligence. This paper proposes a generative design approach using AI. We propose a generative design methodology for producing novel and unique surfaces by faking input surfaces using artificial intelligence networks. These workflows apply to two different artificial networks, cycle GANs and Bix2Bix. This experimentation is introduced to apply to real surfaces. Upon running cycle GANs Bix2Bix and Grasshopper script, the experiment results demonstrated how proposed generative design methodology using AI produced a unique surface version with a higher level of manipulation and a result control. The keywords is generative design, cycle GANs, and Bix2Bix. We have a pilot experimentation too early experimentation, one on Bix2Bix and the other one on cycle GANs. The Bix2Bix experimentation, we used Ryan 3D and Grasshopper to create a set of images that represents two created surfaces, then Bix2Bix network to learn about mapping between pairs of images. And the second part was about cycle GANs. We used several patterns and then used Augmenter to generate a dataset based on manipulating these images that is used as an input to cycle GANs as a training data to learn about the mapping between collections of unpaired images. Results on this pilot experimentation, however, were not fully promising due to 2 points. The first one, the small number of input images used as a training material within the network, and this has a strong reflection on the testing and generating the experiment outcomes. Also, these few images weren't clear enough because Python used to crop them from a fewer number. And the second one, the limited number of out epochs from the cycle GAN network. So the less epochs generated, the more inaccurate outcomes we have. And then the final experimentation. Firstly, we use Blender 3D to generate a set of images to be used as a high quality bump images in the cycle GANs network. And secondly, we model the surface on Grasshopper. We use a Grasshopper to model a surface to be manipulated later on by GANs. And thirdly, created a script to generate color bitmap images for the surface and the bob image in equal. And those two sets of images were later on manipulated by GANs. Finally, we use collaboratory machine learning and data science environment, collab.research.google.com, to manipulate the two input sets, real A and real B, of cycle GANs and generating fake A, fake B, and reuse Grasshopper to regenerate the 3D surface from the GAN resulting images, as we can see the number of generated epochs. And this is the final surface, the final result with what we see on the left and on the right. It's a sample of the Grasshopper script used to generate the images from the surfaces and then convert the images from cycle GANs back to a surface. The research proposes a methodological technique that combines human and technological imagination. We use artificial intelligence as a platform for interdisciplinary cooperation and interaction. The architect samples and sorts external factors where AI controls their importance and weight in the final surface processing. The strategy we are pursuing involves human-machine cooperation. Generative design using AI is promising and helpful in developing futuristic designs by machines, which will be beneficial to tackle new possibilities and alternatives. And this quote from Daniel Pluyan about deep Himmelbau they are developing nowadays. He mentioned that Deep Himmelbau is now able to learn an enormous amount of semantic characteristics to create more detailed interpretations. Deep Himmelbau explores the potential of teaching machines to interpret, perceive, be creative, propose new designs of buildings, and augment designs workflows, and also augment architects' designers' creativity. Its accuracy using cycling based on the number of epochs counted to reach the goal. The accurate transformation is possible by firstly maximizing the training data set as possible with high quality clear images, and secondly by increasing the epochs counted by GANs. And finally, there is a direct relation between the training data size and the number of epochs and the quality of outcomes, and that is what we learned from the early experiment and then applied in the main experiment. Thanks for your listening, and I'm happy to receive your questions.